Spending even a few seconds on Mars would be a profoundly challenging experience due to the planet's harsh and alien conditions. Mars, often referred to as the Red Planet, is the fourth planet from the Sun and is characterized by its cold temperatures, thin atmosphere, and unique surface features. Despite being a prime candidate for exploration and potential colonization, Mars presents numerous immediate hazards to human survival. To start, the temperature on Mars is significantly colder than on Earth. The average surface temperature hovers around -80 degrees Fahrenheit, 60 degrees Celsius, but temperatures can drop as low as -195 degrees Fahrenheit, 125 degrees Celsius near the poles during winter. This extreme cold means that any unprotected exposure to the Martian surface would quickly lead to hypothermia and frostbite. The freezing temperatures would cause any exposed skin to numb and then freeze almost instantly. Even with a highly insulated spacesuit, the cold would be a constant threat, and the suit systems would need to work tirelessly to maintain a livable temperature inside. Without such protection, survival for even a few seconds would be impossible. Another significant challenge on Mars is its thin atmosphere, which is less than 1% as dense as Earth's. Composed primarily of carbon dioxide, with trace amounts of nitrogen and argon, the Martian atmosphere offers virtually no protection from the sun's harmful radiation and provides insufficient oxygen for breathing. Without a spacesuit equipped with a life support system, you would be unable to breathe the Martian air, leading to rapid suffocation. Even if you could manage to survive the initial exposure, the lack of breathable air would render you unconscious within seconds. Another significant challenge on Mars is its thin atmosphere, which is less than 1% as dense as Earth's. Composed primarily of carbon dioxide, with trace amounts of nitrogen and argon, the Martian atmosphere offers virtually no protection from the sun's harmful radiation and provides insufficient oxygen for breathing. Without a spacesuit equipped with a life support system, you would be unable to breathe the Martian air, leading to rapid suffocation. Even if you could manage to survive the initial exposure, the lack of breathable air would render you unconscious within seconds. Mars's low atmospheric pressure would also cause severe problems. At about 600 pascals, the atmospheric pressure on Mars is less than 1% of Earth's sea level pressure. This low pressure would cause any bodily fluids that aren't kept contained by a protective suit to start boiling away due to the reduced boiling point at lower pressures. Essentially, your blood would begin to boil and evaporate at the surface, a process known as ebulism. This would lead to rapid decompression and severe physical trauma, including swelling and severe pain. In addition to these immediate physical dangers, Mars's surface is characterized by a variety of geological features such as dust storms, rocky terrain, and extreme variations in temperature. Mars is known for its planet-wide dust storms, which can envelop the entire planet and reduce visibility to near zero. During such storms, the fine dust can also become a serious respiratory hazard if not properly filtered out by the suit's life support system. The Martian surface itself is covered in a layer of fine, rusty dust that can be abrasive and potentially damaging to equipment and spacesuits. Despite its intriguing geology, Mars's surface lacks liquid water, although there are signs that water ice exists beneath the surface or in the polar ice caps. Any exposure to the Martian surface would be devoid of the life-sustaining resource of liquid water, making the environment even more hostile. The planet's thin atmosphere also means there is no significant protection from cosmic and solar radiation. The radiation levels on Mars are higher than on Earth, which would contribute to an increased risk of radiation sickness and long-term health effects if exposure were prolonged. Moreover, Mars's gravity is only about 38% that of Earth's. This reduced gravity would make movement and orientation challenging. While it might initially feel like a lighter experience, the lower gravity would also affect the functioning of your spacesuit and any activities you attempt. The lack of proper gravity might contribute to disorientation and difficulty in maneuvering, compounding the already severe survival challenges. In conclusion, spending even a few seconds on Mars would expose you to a range of immediate dangers that would be fatal without proper protection. The extreme cold would cause severe frostbite and hypothermia, while the thin atmosphere.
Additionally, Uranus's lack of a solid surface presents another challenge. The planet is classified as an ice giant, which means it doesn't have a well-defined solid surface like Earth or Mars. Instead, beneath the thick atmosphere lies a deep, dense layer of ice and gas. Any attempt to land on Uranus would result in sinking into a turbulent, high-pressure atmosphere before reaching any potential solid core. The idea of standing or walking on Uranus is therefore impossible. You would be continuously sinking deeper into the planet's thick, gaseous layers. The combination of intense cold, crushing pressure, lack of breathable air, and an undefined surface creates an environment where human survival is utterly impossible. Even with the most advanced technology, the extreme conditions on Uranus would make a stay of even a few seconds deadly. The protective suit needed to withstand such an environment would require advanced insulation, pressure resistance, and life support systems capable of handling extreme temperatures and pressures. However, the complexities of Uranus's atmosphere and the challenges of designing technology to withstand such conditions make it clear that even the most sophisticated spacecraft and suits would struggle to keep a human alive for more than a few seconds. In summary, spending just a few seconds on Uranus would expose you to a range of deadly conditions. The extreme cold would instantly freeze any exposed tissues, while the crushing atmospheric pressure would destroy your body almost immediately. The lack of breathable air and the planet's undefined surface add to the insurmountable challenges. Uranus remains one of the most inhospitable places in our solar system, a distant world where human presence is impossible, even for the briefest of moments. The planet's harsh and alien environment serves as a stark reminder of the limits of human exploration and the vast, uncharted territories that